Actions Runner Controller is a Kubernetes operator that is designed to manage and scale self-hosted runners for GitHub Actions. This is a project that has been started by the community, but later on adopted by GitHub. And I'm quite passionate about it because this is what my team and I have been working on for the past year. Actions Runner Controller is now generally available, which means anybody could use it. And of course, by making it generally available, we have published documentation, but who likes to read documentation anyway? So in this next 1 hour and a half, I'm gonna dissect Actions Runner Controller for you. I'm gonna go over the architecture, the design decisions, what are the different components, and then I'm gonna show you all of the different installation steps that you need to go through and the different configurations that you have and limitations of the solution. This is gonna be a long video that is obviously dissected into different chapters, so you can jump to whatever is relevant for you. So go grab that preferred drink or snack or whatever it is, get comfortable, and we're gonna start right about now. Before we start our deep dive, it's very important for us to acknowledge a few things. This is first and foremost a community-based project. It was started by Summerwind, and then Mumusho and Toastgear joined the team of the main maintainers, and they carried over that effort. They have obviously done a fantastic job because this project rose in popularity, and it even got the attention of a lot of people within GitHub, which has led to the decision to adopt this project and migrate it to the GitHub Actions organization so that we can sponsor it and continue developing it. And then in December of 2022, I announced this migration on behalf of my team. Now, don't be fooled. This project is anything but simple. It takes a small village to build it, maintain it, release it, and publish it. And all of these awesome people at GitHub have definitely contributed to the success of this project so far. And of course, Actions Runner Controller would not exist without the generosity of the entire community members and their contributions. So first of all, let's start with the basics. I have spent a ton of time writing this documentation, so you better read it. I'm going to show you where you can find all the information you need in documentation. Then we're going to talk a little bit about the architecture of Actions Runner Controller. So first of all, for you to get to the documentation, it's pretty easy. There's a short link you can go to. It's gh.io/arc-docs. And when you go to this URL, it's just going to direct you right into the quick start page for Actions Runner Controller. Now, the purpose of this page is not necessarily to describe everything about it. It's just to get you up and running as fast as possible without going too much into the details. So it will walk you through the prerequisites for this project, what you need to have installed in your environment. So obviously you need to have like a Kubernetes cluster, or you could use Minikube or Kind, whatever you need. OpenShift clusters are currently not supported. And a lot of people have asked about this. Why don't you support OpenShift? And the reason for that is we only support Kubernetes vanilla because we don't have the capacity right now to test on all of the different flavors and distributions of Kubernetes. So Kubernetes in its vanilla form, as well as EKS and AKS, are the ones that we're going to be supporting for now. If that changes, you'll obviously be the first to know. Also, you're going to need Helm to be installed. We decided that we're going to be using Helm charts to facilitate the installation and setup of Actions Runner Controller, just because it seems that Helm is a sort of a community standard that is pretty much used quite widely. Now, you might ask why not customize and anything like that. We just made this conscious decision. We stuck to whatever the community decided to use also in the previous versions of Actions Runner Controller prior to the adoption. And this is what we're going to be supporting moving forward. If that changes, obviously you're also going to be the first to know. Now, installing Actions Runner Controller is quite simple. You just need, there are two Helm charts. I'm going to describe them, talk about what they are and why we have two Helm charts. But it's pretty simple. You just go through the Helm installation, you supply the configuration. Don't worry, I'm going to walk you through all of this in a bit. And then you configure your runner scale set. I'm also going to talk about what that is in a bit. And then you can just simply get Arc or Actions Runner Controller up and running. And that's pretty much it. There's really not much into it. If you already have a personal access token that you could use for authentication or a GitHub app, then things become quite simple. And then you can just create your workflow and reference the runner scale set in your workflow file, and then the jobs will just go towards Arc, and it's going to create the necessary runners for the jobs to be executed. Now, the next part of the documentation is about Arc. So about Arc is the detailed page where you're going to find pretty much everything. I'm going to spend some time describing and discussing this architectural diagram over here in the next chapter. once we finish the walkthrough of the documentation, but it's pretty much self-explanatory. I spent a lot of time in, describing step by step what actually happens under the hood. So I've written all of this stuff for your information purposes. I would really hope that you would actually read it. Then we talk about the different components for Actions Runner Controller. We talk about the container image. We talk about creating your own runner image, what is contained in the default or the supported runner image that we provide. Obviously, we advise you to create your own runner images over here just because everybody has different needs. And no matter what we do, we're not going to be able to create, an image that satisfies everybody's needs. So we advise you to create your own. And then we talk about how workflows are executed, what happens when you want to scale these self-hosted runners, the software that is already installed on the runner image, so on and so forth. There's also a section describing the different authentication options. You obviously can use a GitHub app for authentication, or you can use a personal access token. I'm not going to go through these details. I personally prefer GitHub apps, although the only problem with it is if you're going to register these runners on the enterprise level, you're not going to be able to use a GitHub app. You have to fall back on personal access tokens just because we don't support GitHub apps on the enterprise level just yet. And then deploying runner scale sets describes everything you need to know about runner scale sets, what they are, why we introduced them. And we talk about the different deployment options that you have, the different advanced configurations that you have with Actions Runner Controller, how you can choose the runner destination, how you can do the authentication, how you can create the secrets, managing runner groups, configuring the proxy, setting the maximum and minimum runners, TLS certifications, custom TLS certifications, using Docker in Docker or Kubernetes mode. These are for the jobs or the workflow runs that have containers in them, whether you're building or you are running a container as a service, using private container registries, configuring your runner image, updating the pod spec, using Arc across organizations, so on and so forth. And the last two sections are the simpler ones. One of them is about how you can use Arc in a workflow. And we talk about why labels are not supported with the runner scale sets. There's a pretty much big distinction between this version and the previous version of Actions Runner Controller, which is labels are no longer supported with it. The runner scale set name is what you would use in your runs on segment to address Arc. And lastly, there's a small troubleshooting section. So if you see some of these problems, you can come here and try to resolve them yourself. However, Arc, in this version of Arc, this specific runner scale set version, is supported by GitHub, which means you can create support tickets with our support team, and we would be more than happy to help you get up and running. Obviously, we cannot support Kubernetes itself. We cannot support your specific environment, but we would help you get up and running. And this is the level of support that we're going to be able to provide. And obviously, if something happens on the back end with the services, so on and so forth, this is something that we are responsible for. All right, that's it. Enough about documentation. Let's actually talk about the architecture right now. All right, so what are the different elements? First of all, we have on the left-hand side, GitHub, right? This is github.com or GitHub Enterprise Server, whichever flavor you're using. And inside of this element over here, you have your enterprise. You could also have an organization or a repository, because a runner scale set can be registered on any of these levels. You can register it against a repository, organization, or an enterprise. Inside your repository, obviously, you're going to have your workflow YAML files, workflow definitions, whether for CI, CD, whatever it is you're using. By the simple fact you're watching this video, then you're already familiar with the concept of self-hosted runners, but GitHub Actions uses machines to run these workflows and execute the work that needs to happen across the different steps and different jobs inside a particular workflow. I've talked about that extensively in my GitHub Actions course. Go check it out. Previously, runners were installed, individually, one by one. You could install a single runner. You need to configure every runner yourself. There were not many great options for managing, the automatic scaling, expansion, and shrinkage of the number of runners you have running. And if there are big organizations, you would obviously want solutions that will allow this automatic, scaling up and down of your self-hosted runners. There are some options that have been created by the community, but there was nothing really provided by GitHub. Actions Runner Controller, we adopted it so that we can provide this option for some of the larger organizations that have, dynamic needs for self-hosted runners. Why runner scale sets and what are runner scale sets? This is a concept that you should be familiar with before we dive into the architecture of Arc. In previous implementations of Actions Runner Controller, the community has relied on two options. You either had the webhooks option or you had the pooling option. Why? Because these were the only two ways that the integration with GitHub was possible. Now, neither of these two is the ideal way to deal with automatic scaling. Neither webhooks nor pooling. Pooling has the problem of hitting API rate limits. It doesn't really scale well. There's a lot of, API requests that are made all the time. It's not really designed for that purpose. And at the same time, you don't always get real-time information about workflow runs. And the second problem with webhooks is that webhooks are not always reliable. The delivery of the webhooks, we don't guarantee an order. Webhooks, they are delivered on a best effort basis. There are no guarantees for the delivery. And if something happens in between, it's very difficult to troubleshoot what happened or to go and do a retry of the delivery of a certain webhook. And then your workflows might end up in some weird state. Runner scale sets is a new concept that we introduced. So runner scale sets are you can need to think about them as a sort of a grouping of self-hosted runners, right? It's like this abstraction that we created on our back end, which represents a group of runners that are homogeneous in nature. So these runners all have the same configuration, the same setup. If you want to have a heterogeneous setup, you were gonna need to have multiple runner scale sets installed or configured. That's how you should approach it. So a runner scale set will spin up runners that are homogeneous. Now, runner scale sets have boundary. You need to think about them as having boundaries, a maximum and lower boundary. And these are the, runner boundaries. So you can have a minimum number of runners all the time, or you could have it scale down to 0. And you can have a maximum number of runners so that you don't overshoot that. You can limit how far the scale set can scale upwards. Now, the nice thing about runner scale sets is that they are addressable by their name. So whenever you have a workflow, you can specify in the runs on the name of the runner scale set. And then whenever a job spins up that addresses that particular runner scale set, the job is queued and then it is assigned to that runner scale set. And then the runner scale set will acquire it. Once it acquires that particular job, it's going to talk to Actions Runner Controller, which I'm going to describe how in a bit, to make an attempt to create a new runner to scale up, because it's going to scale up whenever a new job is assigned to it. It's going to make an attempt to create a new runner. When that runner goes up, it's going to register with GitHub, and then that runner is going to acquire that job and start executing it. And this is the gist. This is the short version of what is really going on. So let us go a little bit more in depth and describe what happens in the flow end to end. So we described on the left-hand side that we have GitHub, we have our workflows, and then in between, obviously, we have the internet and we have the GitHub APIs, but we also talk to the action service directly. There are two elements to Actions Runner Controller. There's the element where we talk through the APIs available or exposed through api.github.com, but we also talk directly to the action service through this endpoint, pipelines.actions.githubusercontent.com. Whenever you have a firewall or a reverse proxy or whatever you're using to access, or a NAT gateway to access the internet, you need to make sure that both of these endpoints are accessible for Actions Runner Controller. Let's say the first step is we create the workflow, and part of the workflow, we are trying to, address a run to our runner scale set, which is called arc test runner in this case. Because Actions Runner Controller is already configured and installed on our Kubernetes cluster, Actions Runner Controller will be composed of two main pods, two main elements. The first pod is going to be called Controller Manager. This is the pod that's going to contain the manager, which has the different controllers that are going to manage the different resources we're going to be creating in the cluster. Actions Runner Controller will rely on multiple components that come off the shelf through Kubernetes, but we have also introduced a number of custom resources that we need to manage ourselves. If you want a list of these custom resources, it's quite easy. You can just go to our documentation and you will see all of the different resources that we have introduced. You can see here on the left-hand side the different types. So we have the auto-scaling listener, auto-scaling listener list, the spec, the status. We have the ephemeral runner. We have ephemeral runner list, ephemeral runner set, ephemeral runner spec, so on and so forth. To manage these resources, we have introduced 4 different controllers, which are as follows. So we have the auto-scaling listener controller, auto-scaling runner set controller, ephemeral runner controller, and ephemeral runner set controller. Now, you don't need to worry about what these controllers are and how they work. They should operate seamlessly for you. What you need to know about these is that the auto-scaling listener controller manages the listener pod. And the listener pod is something we introduced to manage the decision-making about scale. Whenever you install Actions Runner Controller, the first thing that's going to come up is the controller manager pod. Why? Because this has the controllers which are responsible for managing the state of the different resources we need. The controller manager is responsible for creating the resources and making sure that we have always the resources that match the desired count. As you know, Kubernetes works by you specifying, a desired configuration, and the controllers will always make sure through the control loop that you have the desired count. If one of these pods goes down, the controllers are responsible for spinning that up. However, the controllers in this case, in our design, are not responsible for deciding how many resources to create. The listener, in this case, is responsible for deciding how many runners we need to have. So what happens in this case is, whenever you install Actions Runner Controller and whenever you configure a runner scale set, you will have one listener per runner scale set. So each runner scale set will have its own distinct listener, and you can install multiple runner scale sets in the same exact cluster, either on the same namespace or in different namespaces. This is very important, okay? So when the listener goes up, the listener is also an application, a Go app that runs in a container inside this pod. And what happens is that the listener is going to try to connect to the actions backend. Let's actually put them side by side so that we can read and understand what is happening, right? So first step is Action Runner Controller is installed using the Helm charts. The controller manager pod is deployed to a specified namespace, and then a new auto-scaling resource is deployed. And then the auto-scaling runner set controller will call the GitHub's API to fetch the runner group ID for the runner scale set that it needs to be registered against. So the first call is from the auto-scaling runner set controller to api.github.com to fetch the group ID. Obviously, you're going to be specifying, we already specified the authentication mechanism, either via GitHub app or through a personal access token, and it's going to use that for authenticating these calls to api.github.com. Next, the second step is for the auto-scaling runner set controller to call the API one more time to fetch and create the runner scale set, right? So the runner scale set doesn't exist right now. We just configured our controller. The controller is responsible to call our backend and make sure that we have created a runner scale set. And at that particular point in time, if this call is successful, you should be able to see your runner scale set in the API, either on the repository, organization, or the enterprise level. After that happens, the runner scale set listener, not necessarily the pod, but the application that is running in the pod, it's deployed. And the auto-scaling listener controller is responsible for making sure that this listener is always up and running based on our configuration. So when you do the Helm install for the runner scale set, the auto-scaling listener controller is responsible for making sure that it spins up this listener pod and that this pod is always running. Now, when this pod goes up, it's going to try to make and establish a long pole HTTPS connection to the actions backend. So this is number 3 over here. The listener will make a call to pipelines.actions.githubusercontent.com. Using the same authentication mechanism, it's going to create a long pole session, which is going to wait for jobs that are assigned to this particular runner scale set. Number 4, when a workflow run is triggered on the GitHub side, this is gonna send a message through the long pole connection that we have created with the listener. So the actions backend is gonna send a message to the listener saying, I have this job that is assigned to you, right? I have this job that is directed towards you. Can you accept it? There's some, handshake mechanism that's going on. So can you accept this job? Do you have the capacity to handle it? And the listener is gonna make a decision based on the configuration that we supplied, maximum, minimum runners, so on and so forth. And it's going to say, yes, I accept this job. When the listener accepts this job, it's going to send a message back to the backend saying, yes, this job is mine. Please assign it to me. Then the backend is going to assign this job to the listener. When the job is assigned to the listener is going to go and try to make an attempt to create a new runner. And by creating a new runner, I mean creating a new runner, ephemeral runner pod. And again, these runners are not static. These runners are ephemeral. So they will go up and down. Once they finish their job, they're destroyed. What happens in this case is the listener is going to go and it's going to try to patch the runner set resource, which is a custom resource we introduced. And the runner set resource in this particular case, and don't confuse it with the runner scale set. I know the names are very confusing, but now we're talking about the architecture of Actions Runner Controller, okay? So we have a runner set resource. This runner set, you can think of it as a grouping of self-hosted runners, and it has also a lower bound and an upper bound. The listener can patch this resource. So it can make a call to the Kubernetes API saying, I want to change the configuration of this particular resource. And in this case, the listener will come and patch the ephemeral runner set resource and say, bump it up by 1. I want a new desired runner to be created. Once this patch happens, the controller, in this case, the ephemeral runner controller, because it has a reconciliation loop, it's indefinitely running to make sure that we match the desired configuration. And because we changed the desired configuration over here, now the controller says, okay, I have a new desired count, and my actual runner count is less than that desired count because we added 1 to it, right? And in that case, the ephemeral runner controller is gonna go and try to create a new runner. And it's gonna create a new runner pod in this case, whereby inside this pod, you're gonna have the actual runner image running as in a container. And then this runner, when it's created, and when the application inside this container starts running, it's gonna try to authenticate to Actions Service backend. And it's gonna use a just-in-time token to do that authentication. So this is one of the advantages of using the new mode, is it's a bit more secure. We don't inject the personal access token or the app installation token from the GitHub app as was done in the previous version of Arc. Right now, we create a new ephemeral token for the specific runner that is sent to that runner, okay? And then that runner can use that token to register itself against the backend. This token has very limited authority and it cannot really do much, so it can only register the runner. And once the runner is registered and its status is up, then the Actions backend is gonna assign the job to that particular runner. And then once the runner receives that job, it's gonna try to run it and execute it, and it's gonna upload the logs, and it's gonna report back the status continuously, so on and so forth. So at this point, if anything happens to your runner, the job is not completed, connection breaks, whatever it is, this is where you need to start troubleshooting, because the connection between the runner and the Actions backend might have been broken. This will definitely happen in the case if you're using a reverse proxy, or if you're using some NAT gateway, you have some weird firewall rules, whatever it is you have in between the runner and the Actions backend. This is where things could go wrong. And of course, this applies to pretty much everything in this cluster over here. Anything you have between the controller manager pod, the listener pod, and GitHub, this is where things could start breaking, right? And we've seen all sorts of stuff. Also, it's very important whenever you're doing your setup to make sure that the runner skill set listener has access to the internal Kubernetes API so that it can patch the ephemeral runner set. Extremely, extremely important. Now, when the runner completes this job, it's going to report back the status, and this is when everything is done. The runner, once it finishes, it just removes itself, and the next reconciliation loop, the desired count will match the number of actual runners running, and then there's pretty much nothing to do unless we have a new workflow that is running. And if you have multiple workflow runs coming in simultaneously, the listener pod should deal with that pretty easily, as long as we're creating runners within the boundary of the minimum and maximum configuration that we have specified. We talked a lot about the architecture. We talked a lot about the internals. So let me now show you how everything actually works. We talked a lot about the theory. Now let's get actually into practice, and let me show you how you can set up Actions Runner Controller yourself and different configuration options. We're going to start with the Actions Controller repository because I just want to clarify a few things that are confusing to a lot of people. Adopting this project was a bit troubling. Why? Because we had already, in the repository, a working solution for a lot of people. And we obviously didn't want to break this while still introducing the new and improved way of dealing with, self-hosted runner scaling. And that is why in a lot of the sections of this repository, you're going to start seeing, this distinction. Actions.summerwind.net and actions.github.com. Actions.github.com is everything new we created when Actions Runner Controller was adopted. This is the stuff that is actually supported by GitHub, and actions.summerwind.net is everything that the community still maintains and supports itself. So this is a collaboration with the community, and we didn't eliminate the community from the equation. Obviously, we're still working quite closely with the main maintainers. Yusuke has been doing a fantastic job, Mumusho, in maintaining this and responding to the community queries. The community is quite active, and we definitely want to keep that ongoing. However, we introduced the new APIs, the new custom resources, and the new everything in this new namespace. So what we've done, instead of creating another repository or forking the project or any other mechanism, which is not necessarily great, we decided to create a new namespace within the same operator and to put all of the new stuff in it. So here you will see all of the new custom resources that we have created. Auto-scaling listener, auto-scaling runner set, ephemeral runner set, as well as, the different tests, so on and so forth. You can see this also this namespacing on the level of the controller. So this is where the controller logic is defined, actions.github.com and actions.summerwind.net. So if you go here, you will see the different controllers for the different resources. And these controllers are responsible for making sure that, we spin up the necessary pods to maintain the desired configuration. And this is where pretty much all of the controller logic resides. And again, if you go back to the root, you will see also here in the command folder that we have a couple of things. So this is where the GitHub Runner Skillset Listener application is located. So this is where the listener's code base is available. This is the listener that connects via long polling to our actions backend. So if you want to come here and read the source code and see what's happening, this is pretty much it. It includes all of the different tests, so on and so forth. So when we deploy this controller, we are running different applications, right? So in the first pod, we mentioned that we're running the controller manager, which was the controllers folder. That's what you've been seeing. And then in the second pod, the listener, we are running this particular package or this particular application, right? And the rest is, just stuff that is needed for the proper functioning, as well as different packages that are required by most likely the former controller. Now, one thing that is very important, you will see here there's a folder for runners, right? And in here, you will see different Docker files for the different runner configurations. We are not maintaining those. So GitHub is not responsible for maintaining these runner images. These runner images are part of the old community managed version of Actions Runner Controller. Our runner image is hosted in another repository. Anything you see in the folder runner, that's part of the old Actions Runner Controller. We are not, or GitHub is not maintaining that anymore. And we don't have plans to take over the maintenance of these runner images. So let's be very clear about that. Our runner image is actually maintained in the self-hosted runner repository that is hosted in the actions org. So if you go to github.com/actions/runner, this is where you will see the code for the self-hosted runner. This is the same runner that runs in, your self-hosted environments. It's the same runner binaries that we use in GitHub hosted runners, right? And then if you go to this folder images, you will see a Docker file over here. And this is the Docker file that we are using and officially supporting as part of the new Actions Runner Controller offering. So whenever we create a new runner release that you can pretty much see over here. So yesterday we released the version 2.306.0. Automatically, we are publishing a new runner image. So if you go to this package over here, you will see that yesterday we published, or the latest tag has been applied to the version 2.306.0. So whenever you pull the latest image, you will get, the latest binary, and this is the reference for it. In our Helm charts, we are pointing to this runner image. Now, what we advise you to do is to come here, either one of two options. So either use this image as your base image and build on top of it, or if you don't like what we're doing, you can come here and create your own runner image. So you can specify or use whatever base image you like. In this case, we are using the image that is published by Microsoft, and it is using Ubuntu as a base image. If you don't like Ubuntu, you want to use something else, feel free to do that. You can use whichever distribution you want, as long as it is supported by our self-hosted runner binaries. So then you can come here and configure the same working directories, and then you install the same binaries. This one is for the runner binaries, and this one for runner container hooks, and it is used in the Kubernetes mode to spin up containers that run container jobs. And we also install Docker because it's needed for the Docker in Docker mode. So if you don't need this, you can also eliminate some of this stuff. Now we are adopting a slightly different way of building runner images. So we have the first image for, building the runner. And then the second one is the one that's a bit stripped down, that is actually used to run the different binaries. Okay. So this is how we are specifying it. And as you can see, also, we are using the 1001 user ID as well as 123 for the group ID. Also feel free to change those as needed. Now you will notice that nothing really is installed besides the runner binaries, the container hook binaries on this runner. And we don't plan to install anything. We want to provide a bare bone, stripped down version of the runners, because we, first of all, don't want to maintain all of these different third-party distributions for different applications. We definitely don't want to come in and create a 2 GB runner image. We want to keep it as simple as possible. And we will advise you to create your own, customize it whichever way you like, and add whatever you want on top of it. And this is the philosophy that we've adopted for now and that we are gonna move forward with. Obviously, coming back to the Actions Runner Controller repository, you will notice here that we are referencing different packages, and these are the packages that have been previously released. These are the runner images, the different variations that have been provided by the community before. Let's discuss a little bit what are these packages, because they also are the source of a lot of different confusion. Okay, and I understand it's a bit messy here, but yeah, I will try to clarify it as much as possible. And the reason for that is when we migrated this repository to the Actions organization, there were a lot of different, we didn't really want to break anything. So there were some leftovers, there were different problems that we needed to tackle. So first of all, I want you to ignore these packages. Actions Runner, Docker and Docker, Actions Runner, ignore them. Okay, I'll explain why in a bit. Actions Runner DI and D rootless, ignore it as well. Actions Runner Controller 2, ignore it. We need to clean these up. Actions Runner Controller Charts, Controller 2, also ignore it. Things you want to focus on are Actions Runner Controller Charts, GHA Runner Scale Set Controller. That's the first package that is relevant. Second one is Actions Runner Controller Charts, GHA Runner Scale Set. Second package that is relevant. And then GHA Runner Scale Set Controller. These are the three packages that are relevant from this particular link, and I will explain these. So first of all, the charts, the Helm charts that we are publishing, we're not publishing them through the traditional way of using GitHub pages. We don't think that this is the appropriate way to publish Helm charts. We are against it. It's been used as a hack or as a workaround to publish these charts. We don't really agree with this approach. Helm supports, OCI images, and packages supports the publication of OCI images. That is why we are bundling these charts, as OCI packages, and we are publishing them. So whenever you try to install the Helm chart, you actually download this image from our packages, and then you install it, as opposed to downloading it from downloading a YAML file from GitHub that is hosted via GitHub pages. So this is the first Helm chart. This is the Helm chart that will install the controllers. Okay. And then there's the second Helm chart, which is responsible for configuring the runner skill set, which is going to enable your listener. Okay, so there are two charts. One of them is to install the controller, the first one, and to configure the controller, which namespace they need to belong to, what is their name, so on and so forth. And then the second Helm chart is to configure your runner skill set. And by configuring the runner skill set, the listener is going to go up. Now, you need to be aware of a couple of things. This Helm chart is not going to install your listener. It's going to allow you to configure the runner skill set. And then the listener, it uses the same image as the controller. So the application for the listener as well as the controller manager, they're bundled in the same container image. Now, why do we have two Helm charts? Because we thought at the beginning, we want to provide a very quick and easy mechanism for people to get started with Actions Runner Controller. And there's really nothing easier than just having a Helm chart for the controllers, install, configure whatever you need, and then another Helm chart to configure runner skill sets. Why another one? Because you might want to configure different runner skill sets, right? Because as I said in the beginning, each runner skill set is homogeneous. It's going to contain the same type of runners, same name, same everything, right? So you cannot have different types of runners running at the same time. So you cannot have, Debian runners and Ubuntu runners and maybe runners with some applications, as well as runners with some other variation of applications running under the same runner scale set. That's not going to be possible. That's why you might want to manage your entire configuration via Helm chart, so you can do multiple installations of this particular Helm chart so that you can have multiple runner scale sets running in parallel for different organizations, different repositories, different enterprises, under different namespaces, you name it. And you're going to see how in a little bit I'm going to demonstrate this. And then the final package we have is the actual container image, which contains pretty much the code that I've just showed you in this repository, which contains the code for the controllers, right? Controller manager, and it contains the code for the listener, as well as the code for exposing the metrics and all of that other fun stuff. These are all the elements you need: the Helm charts, the controller image, as well as the runner image. Three main components, right? Two Helm charts and two images. The other packages, you can ignore them. They are either not public or, they are not accurate. They came as artifacts as part of the migration. Now, you might be asking, where are the runner images that are published for the old Arc? And it's quite simple. So if you go to github.com/actions-runner-controller, this is an organization which contains all of the legacy stuff. Okay, so it contains, the Helm charts, the previous ones for the previous versions. They are still, the Helm charts are being published still through GitHub pages. And this is the repository where these Helm charts are being published. So you can see here the index.yaml file for the previous Helm charts. This is pretty much it. And all of the new releases are being published to it. But nothing regarding the new runner skill set mode has any relationship with this. Okay. And the second thing you will find here is also the packages, which are the old runner images. So here is where you will find the images that map to these files over here. So let me show you these images. Again, we said that we have this folder runner, and inside this folder we have these different Docker files, right? So whenever we build and publish, this is where we are publishing the images, right? Inside the Actions Runner Controller organization. And this repository is inside the Actions organization, right? So when we moved stuff, we moved this repository, and then the old packages remained under the old org. And you can, if you click on either of these, you will see that they also have, the runner images, they have the latest 2.306.0, but they have different variations. So we have one with Docker and Docker, one that is quite vanilla. And then we have the image for the old Actions Runner Controller, right? And then we also have the Actions Runner, Docker and Docker rootless. Now, you will see that the last published was 24 hours ago. Yes, we are still helping the community maintain them, but GitHub is not directly maintaining them. You can see here, Momusho or Yusuke is leading on all of this effort, and we are supporting the community in this effort, but we don't have plans to maintain them ourselves. So what are the other elements that are important for our setup? I would recommend that you ignore the documentation that is available here, at least for the the new mode, because all of this has been migrated to docs.github.com, and this is no longer relevant or maintained. I have a pull request that is gonna clean up this documentation moving forward. Obviously, we have a lot of different workflows. We have for testing, end-to-end testing, so on and so forth. All of this documentation over here is for the old mode. All of the new stuff is on docs.github.com. Okay. Now, let us create a new setup. Let's move on with the actual setup. I'm going to create a new code space. And why code space? Because, it's the easiest way to create a new environment that, I can install whatever dependencies I need and the tools and all of that stuff. So I don't have to worry about polluting my local environment and everything like that. I'm going to spin up an 8-core, 16 gigabyte of RAM. You don't need that much, obviously, but to run Minikube and all of that, I think this would make the most sense. And this is going to spin up my Visual Studio Code. It's going to take a little bit for this code space to spin up. So we're going to wait for it. Awesome. You don't really need the source code to set up Actions Runner Controller. And so you don't really need to clone the repository or anything like that because all of the packages have already been published. I personally just created a code space because I want to, just use it as my compute, not necessarily for any other reason. And because it just comes pre-bundled with a lot of the tools that I already need. So I don't have to worry about setup and all of that funky stuff. And what's nice about code spaces that I can also SSH into them, so I can pretty much do anything I want directly from the terminal. So first things first, we need to make sure that we have all of the tools that we need, right? And maybe a better idea would be to try to SSH into the code space as opposed to using my VS Code. So here we are, I just SSH into it. And by the way, this will not work locally for you. This is just an alias. You can use CS SSH and then you provide the code space's name. I created an alias to make my work easy, and I'm using the GitHub CLI for this. I'm inside the code space right now. Let's make sure that we have all the tools we need. First of all, do we have Minikube? And we do. That's what we're going to be using as our Kubernetes distribution, and it's going to create a single node cluster for us. I'm not going to create a new Kubernetes cluster just for the purposes of this demo. It just defeats the purpose. And the second thing we're going to test is that we have Helm. So Helm is already installed on my code space. Let's see which version we have. All right, 3. Great. I also will need kubectl. Let's see, do I have it? Yes, perfect. Okay, great. And I think we are ready. The first thing we're going to do is we're going to start a new Minikube cluster. So we can do that with Minikube start -p. P is for profile, and we're going to call this one, I don't know, arc. You can call it whatever you want. Then we're going to specify the number of CPUs we want. Let's say 4. Then we specify the number of the memory. Let's say we want 8 gigabytes. And then I'm going to add a couple of things. You don't necessarily need to do them yourself. It really depends on what type of configuration you want. Now, this particular, configuration is not necessarily needed by your environment. But in my case, I'm going to be using OpenEBS for dynamic provisioning of persistent volume mounts. Or persistent volumes, and OpenEBS has this requirement where we need to map or mount run-udev onto the cluster or the node itself, and this is what it is used for. I think the rest is pretty much vanilla. We don't really need anything else to get started, and I think with this I can just execute it, and now it's going to try to create a new cluster for us using Ubuntu 20.04. Obviously, your Kubernetes setup is going to be much more complex than this. Maybe you're even using some managed Kubernetes flavor like AKS or EKS, whatever it is. The setup shouldn't vary that much. Now, of course, a lot of different enterprises have different requirements, different policies, different, restrictions on what can be installed and cannot be installed. I'm not going to be able to go over all of these things today. I'm just going to show you a vanilla setup. And then for the specifics of your environment, you're going to have to, either work with GitHub directly through expert services or by doing some research yourself on some of these requirements. I'm going to show you what are the different elements, and then you need to make the decision for yourself how these will fit into your particular environment. What Minikube normally does is that it creates a VM or a virtual machine in your environment where it's going to be running, that particular Kubernetes flavor. And in this case, because I'm running in a code space, which is already a container, so it's going to use the Docker driver in this case, and the node is going to be an actual Docker container as opposed to being a full-fledged VM. And as you can see, Minikube has finished its work. And if I type Minikube status -p arc, you always need to specify the profile now because we use the profile. You can see that the host is running, the control plane is running, everything else I need is up and running. Now, the next step for us is to actually configure the values.yaml file for the Helm charts. And we're going to do that quite simply. So if you go to the repository, and because I have the repository already checked out here, you can either download this file from, the repository itself, or you can recreate it yourself, or there are many ways. Just grab yourself a copy of the values.yaml file. So this is the root folder of the repository, and you can see there's a folder called charts. So we're going to go into sorry, I'm not sure you can see this. We're going to go into the charts folder right here. And if I do a listing, you can see that I have the first chart here for the controller, and then I have the second chart for configuring the runner scale sets. Okay, so we're gonna first create the values.yaml file from the controller. So I'm gonna go into this directory, and then I'm gonna do another listing, and you can see I have a values.yaml file. Again, this values.yaml file is a template. So what I would recommend you do in this case is for you to copy this file into some other location. So let's say I'm going to create a new directory in my home folder, and I'm going to call it, sorry, not like this. I'm going to create a new directory, and I'm going to call it arc configuration. Okay, so I'm going to go to arc configuration right now, and I'm going to try to copy the values.yaml file so that I can configure it. Let's make a couple of folders here. First one, we're going to call it controller, and then we're going to make another folder. We're going to call it, runner scale set 1, let's say. Okay, and then maybe you want to have another runner scale set, so you're going to need another configuration file. Let's call it runner scale set 2. Okay, so you can have as many as you need. Obviously, your naming convention, apply whatever you want over here. So we're going to copy the first values.yaml file from our checked out repositories. So again, charts, and then GHA runner controller set, runner set controller, and then values.yaml, and we're going to copy it to the folder home/arc configuration/controller. Okay, that's the first step. And then we're going to copy, we're going to make 2 copies of the other values.yaml file now. Okay, so workspaces, actions, runner, controller, charts, and be careful here. We're not copying the same file. We're copying the file from the GHA runner skill set chart now. Okay, the previous file was being copied from the GHA runner skill set controller. These are 2 Helm charts. So always keep this in mind. Now we're copying this file into home directory, arc configuration /runner scale set 1. So we're going to make 1 copy in this one, and then we're going to repeat this and make another copy in the second folder. Okay. Now, if I do a tree, you can see here that I have a values.yaml file inside my controller folder. I have another values.yaml file inside my runner scale set 1, and I have another values.yaml file inside runner scale set 2. Let's start working inside the controller. Okay, so we have our values.yaml file over here. We're going to open Vim, open any editor you want, doesn't really matter, so that we can start configuring our controller. And as you can see here, this is a pretty much a regular YAML file. Yeah, I mean, you can just use any YAML validator. Really, there's nothing major going on here. So let's talk about the different values and what are the different configuration options you could have. All right, so the first item you can configure are the labels that are applied on all of the resources that are created by this chart. And the way you can understand this is just a very simple key value, like dictionary or structure. And you can see where they are being applied by going to the, our repository, go to the charts folder, and then GHA runner skill set controller. You go to the templates, and then pretty much everywhere it says include, sorry, not this one. Everywhere it says include GHA runner skill set controller labels. This is pretty much where the labels are going to be applied, and they're going to be applied to this deployment. They're going to be applied to this service account. And yeah, there are a bunch of other places, right? So you can configure these labels to be whatever you want. Labels will help you identify the different resources. You can, I don't know, have a certain naming convention applied on them, or you can specify that these labels belong to, I don't know, these resources belong to a certain organization or a certain team. There are many reasons why you would want to use labels to tag your resources. The second option here is the replica count. You can obviously specify that you want multiple replicas of the controller manager. However, at every single point in time, there's going to be only one of these replicas that is responsible for the reconciliation. Otherwise, things are not going to work because you're going to have a split brain problem. We're not going to talk about a lot of details about this, but there is a leader election algorithm that is applied that's going to select one leader out of these multiple replicas to be always the one that's responsible for the reconciliation. So if you want some form of high availability, this could be an option for you, whereby if one of them goes down, a leader election will pick up another controller to take over the reconciliation work. Next is where you specify the image that's going to be used for the controller manager as well as the listener pods. Okay. And here you don't really need to change this unless you are mirroring this image inside your own private registry, because you don't want to pull from the public registry for whatever reason. You might want to scan these images before you deploy them in your cluster, or do whatever you want. So the idea here is you can specify whatever repository you want. This is the default. I showed you where you can find this package. The second option is to specify the pull policy. And then the third option is to override the image tags instead of pulling the latest version. So this is where you can specify a specific version of Actions Runner Controller to run. And the reason why you might want to do this is maybe there are some breaking changes in future versions and you want to be prepared for that. So you don't want to always pull the latest image and run it. You want to be more in control of what you are deploying and what you are running. And this is the way to do it. And obviously what is not described in this values.yaml file, but image pull secrets can also be configured if you are running this. Oh, actually, it's right over here. Sorry, never mind. So you can specify the image pull secrets. So if you are pulling this image from a private registry, you need authentication. This is where you can do it. I think this takes as a reference a secret that you can configure on the Kubernetes level. So you don't have to provide the secret as a hard-coded plain text value over here. Now, when we are creating the controller pod and all of the different resources, we obviously have default names for those that are compliant, with the Kubernetes API limitations and storage limitations. However, if for whatever reason you need to override this and specify a different application name, you can do this with these two parameters. And again, the way to understand those is if you go to our repository, you open the helpers.tpl file, you can see here all of the different places where the name overrides are being used. Obviously, these names are going to be truncated because we have very strict naming limitations that we need to abide by. I wouldn't recommend you change any of these unless you really know what you are trying to achieve. The default values are reasonable, and there's really no particular reason why you would want to change them unless you are an advanced user. Next, this is where you can define environment variables for the controller pod. Obviously, we create our own environment variables for these pods, but if there's for whatever reason you want to, provide some information to the controller, or you want to inject some environment variables, or maybe you want to inject environment variables that are coming from a secret. So you can also specify these in your values.yaml file. You can specify here a secret reference from which this template will pull the value of and specify it as an environment variable. Next is where you can create your own service accounts. Obviously, the controller needs to have elevated permissions on the cluster. we have our own role definitions, right? So you can see here in the Helm chart, we create the cluster role with all of the different, the API groups and the resources that we need access to, along with the different actions that we want to apply on these resources. So this is very important if you are using RBAC, role-based access control. If you don't want to rely on the defaults, you need to create these on your own. You need to create the service accounts on your own if you don't want us to create them for you. And then you need to specify them if you have your own custom configuration. Maybe you don't like our permission structure or for whatever reason. However, these permissions are the bare minimum that we need so that the controller can function appropriately. If you create your own roles, if you create your own service accounts and whatever, and if you miss any of these permissions, we have no guarantee that the controller is going to be working. Okay, so if you start seeing authorization problems, pods are not spinning up appropriately, in the logs, if you start seeing authorization issues, API responses that look weird from the Kubernetes API, then come back and revisit the permissions that you have applied for that particular service account that is being used by the controller and the resources. Okay, these are very important. So we have multiple roles, multiple role bindings. You can just read them inside these charts. They are very well defined, and you can pretty much, see everything that we are requiring permissions for. This is where you can specify pod annotations. This is where you can specify the pod security context. Obviously, the controller pod can have, a security context on its own. Maybe you want to specify an FS security group, or you want to specify some resource limitations, or, the user level that you want to run this pod at, or the group, or whatever it is. This is where you can specify it. Now, there's a small caveat. In the time of making this video, this security context did not apply to the listener pod. The option to configure the security context for the listener pod was not available yet. We are working on a fix for this that we're probably going to release in future versions, but I'm not covering it in this video because it's not out yet. All right, this is where you can specify the resources also for the resource limits, the quotas on the controller pod. And again, this doesn't really apply to the listener, so just be careful and make sure you understand this point very clearly. Node selector is you have a particular node that you want to bind to this pod. You want always this pod to spin up on a particular node for whatever reason, even though we don't recommend it. This is where you can specify it, tolerations, affinity, priority class name, all of these things, you can specify them from the Helm chart. Now, evidently, if we're missing anything, we recommend that you create your own charts and customize them whichever way you want. You don't always have to pull our charts, and you can modify the resources whichever way you want. You can also apply some of these configurations post setup. So it's all up to you how you want to manage this. We think we did an okay job in defining, the defaults, and we think the defaults are quite reasonable. Next are some feature flags and configuration flags. So we have a couple of them. First of all, you can specify the log level. All of the logs are being streamed to standard output, so you can pull them and push them to some whatever logging storage solution you have. It's quite easy. So if you want the logs to be quite verbose, you can specify the debug level. This means that you have all of the exceptions, errors, whatever it is, you can see them in your logs. Be careful because I don't think we do, but it is possible that through the debug log level, some confidential information might be exposed. So if you are pushing these logs somewhere else, if you're copying them, whatever, make sure you vet them and make sure that they don't contain any confidential information. Next is the log format. You can, by default, it's text, but you can also use JSON. The next thing you can configure is watching single namespace. So obviously the way we have designed this controller is to observe changes in different namespaces. And this is very valid if it's trying to modify resources in different namespaces. But if you want to limit its what it observes to a particular namespace, this is where you can specify it. Next is a bit of a convoluted concept, which is called the update strategy. We have two modes, immediate or eventual. And this is related to a situation where it's a bit tricky. But the problem is if you have your controller running and you have a number of jobs that are either pending or they are also running, right? So you have your controller set up and you have, let's say, 100 jobs that are in a pending or a running state. And then you apply an upgrade. So you modify the Helm charts and then you upgrade your solution, right? There's a big question of what happens and when do you apply this upgrade? Do you apply it immediately or do you apply it when all of the jobs have finished? If we apply this patch immediately, there is a situation where while we are applying this change, the controller will destroy the existing resources. It's not going to shut down the ephemeral runners that are running. These are just going to continue behaving as normal. But the ephemeral runner set, for example, and the listener and these custom resources that we created, they're going to be removed, terminated, so that we can apply the new changes that have been specified through the upgrade, through the patch, right? And what this will do is whenever the listener and the ephemeral runner set go back up again, it's going to try to provision the same number of runners that are already in a pending or a running state. Obviously, these new runners are not going to do anything. They're not going to be able to acquire the jobs because these jobs have already been assigned to other runners. But still, this could lead to a situation where you have some level of over provision. And if your cluster is being hammered by workflows and you already have, like, let's say, I don't know, 500 runners, your cluster might not be able to handle this over provisioning of resources. So obviously, we want to avoid such a situation. And the way you would avoid it is by changing the update strategy from immediate to eventual. And what eventual will do is it will remove the listener and the ephemeral runner set. So if folks using or creating workflow runs addressing this runner scale set, these jobs will not be assigned, or at least they will not be assigned to the runner scale set because the listener is not there to acknowledge those jobs, right? It's been removed. And then what will happen is it's going to wait until all of the existing jobs that are pending or running drain, so they finish. Once that is done, the controller is going to apply the upgrade, and then the listener and the ephemeral runner set are going to pick up the new jobs, and then they're going to execute. Now, obviously, this is going to lead to delays of an unknown duration, because the duration of the delay is based on how many jobs you have running and how much time they need to finish. It's based on the draining duration of your existing jobs, right? So this is the risky aspect of it, but also it solves the problem of the over provisioning. When these go back up, they're not going to recreate the resources because they're going to start fresh. They're just going to start dealing with the new jobs that have been queued. Be careful about this. Don't change the update strategy unless you really understand the implications of it and what is really happening. We are still trialing this mode, so we know how it's going to behave, but there might be scenarios that we didn't really anticipate. So also, if you face issues with this, please do let us know and we will try our best to fix it. And that's it. This is everything about the controller configuration. Now, obviously, you don't really need to create a values.yaml file. You can apply the changes to this configuration through the CLI. I can show you now how it's done. But yeah, you can also modify any of these values and apply any of the configuration you want. I'm going to keep everything to the default because in my opinion, the defaults are quite sensible. Maybe the only thing I will do is I will change the tag, but I'm not going to change it from the values.yaml file. I'm going to change it in the CLI. So I'm just going to exit this values.yaml file. And now we're going to, start installing. So let us proceed with the Helm chart installation of the controller. Okay. And we can do this very easily with Helm install, and then you can specify the installation name. I'm going to use arc in this case. I'm going to use the / because I think it's easier to read if I go down the line. And the second thing I'm going to do is I'm going to specify the namespace where I want this controller to be installed. Let's specify it like this, and then we're gonna call this arc systems. You can call it whatever you want. You can specify it as an environment variable, and then we're gonna specify create namespace, because if this namespace doesn't exist already, which you can create it standalone separately, but Helm can also take care of that for you. And then this is how you can override some of the values in the values.yaml file if you don't want to change the file itself, right? So you can say set image.tag in this case, because I want to use a specific image version of the controller. And you don't really need to specify this because it's always going to pull the latest, which I recommend, or it's going to pull the image tag that is appropriate to the chart version you're trying to install. But in whatever case you need to override it, this is how you can do it. And then you can specify the file, the values.yaml file, right? So the values.yaml file in my case is located in home, code space /arc configuration /controller values.yaml. And then the last step is to, we have two more steps. One of them is to specify the Helm chart we're going to be installing, right? So here you can either specify the Helm chart that is available locally because we cloned the repository. So it's going to be using the one from the master branch, which I don't recommend because, it could be unstable for whatever reason. Or you can use the OCI package that we have published to GitHub packages. You can do it with this value over here. So you can see it's going to our actions organization and pulling this particular package from our packages registry. And then the last thing we can do is to specify the version of the Helm chart we can use. And in this case, I want to specify version 0.4.0. Always make sure that the version of the Helm chart matches the image tag. We try to guarantee as much as possible that there is no mismatch between these two. They're going to go hand in hand. But again, for whatever reason that these drift, be careful when you specify these. The latest option is also fine. But in this case, I also don't recommend using the latest. Just specify this version and ignore this one because it's going to be pulled from the default values in the Helm chart itself. And then when you run this command, you can see here that it pulled the image. You can verify that the SHA matches the one that is, it already did the verification, but if you want to be extra secure. And then you can see here that it has been deployed and this is the first revision. And now if we do the following, if we do helm list -a, you can see here that arc is deployed. You can see when it was deployed and you can see which version of the chart is currently running. Now, what does this actually mean for us? If we do kubectl get pods -n arc systems, because this is the namespace where we installed our controller, you will see here that we have our controller pod already up and running. If this is not running in a running state, that means we have a problem. Revisit your values.file configuration or revisit the settings that you have passed in the CLI and make sure that they are correct. You will see here that also this name is quite lengthy. We are working on shortening this name so that you don't hit any API limitations. That's probably going to be fixed in future releases of Actions Runner Controller. Now we have the controller up and running. We can also do one more thing extra, which is to inspect the logs. So we can say kubectl logs pod, then we provide the pod name -n arc systems. And then if we inspect the logs, we are seeing some infos, but we don't see any errors. That means we are in an okay situation right now, and then there are really no problems. Obviously, the controller is not going to do much right now. It's just going to stand idle just because there's really nothing configured yet. There's nothing to reconcile. So in order for us to actually install and configure the runner skill set, we need to use the second Helm chart. And let me show you right now how we can do this. So let's go to the previous folder and let's go to the runner skill set 1. This is where we have copied the first values.yaml file, right? This one is for the second Helm chart, which is the GHA runner skill set Helm chart. Let us again open this values.yaml file in Vim, and this is where we start configuring things. The first things first, GitHub config URL. This is where you want to register your runner skill set and subsequently the runners against. This could be either a repository, organization, or enterprise. However, this cannot be multiple values. It's just a single value. And in our case, we're going to install it on a test organization that I have created for the purposes of this demo. So if I go to my browser, this is going to be my test organization. This is the URL for it. So let me copy this URL. And then if you can see here, I have already a GitHub app configured and installed. I'm not going to go through the configuration and installation of a GitHub app. I've done this many times in other videos. You can go and check them out. We are going to use this application over here. And you can see it doesn't really require a lot of permissions. So let me just authenticate very quickly. If we go to permissions and events, we don't really need a lot of stuff. We just need to be able to have administrative privileges on the repository if we're going to install repository level runners. However, on the organization side, we're probably only going to need read and write access to self-hosted runners. That's it. We don't need anything else. If you want to install them on the repository level, unfortunately, you still need to supply the administration permission. You can read more about what are the permissions required in our documentation. Going back to my values.yaml file, let us actually paste the link to my organization, and that's it. You don't really need to change anything. Just copy the link to the org, put it here, and you're good to go. The second thing we want to do is to configure the GitHub secret that we're going to be using. Obviously, a lot of people are going to complain about this. Should we really put the value of the secret like this inside our values.yaml file? You don't have to. You can obviously do it like this by specifying it yourself, or you can create the secret in Kubernetes and then just add the reference for it over here. And this is what we're going to be doing right now. So we're going to create a secret that's going to contain our GitHub app values, and then we're going to add the value of this secret or the reference for this secret in our values.yaml file. And the way we're going to go about creating this secret, I'm just going to paste the command over here in this editor just for clarity's sake. So you can see here, we're going to create a secret. We're going to call it a Nebu GitHub app, and then we're going to put it in the namespace that is not the namespace where we installed the controller. We're going to put it in the namespace where we're going to be installing the runner scale set and where the runners are going to be created. This is very important. Otherwise, you're going to get authentication failures because the controller is not going to be able to pull this secret. The second thing is we're going to provide the GitHub App ID, which you can get it from the configuration page. And then we're going to provide the installation ID. And this one is a bit trickier because it's not in the configuration page. And the way you can find the installation ID is by going to the settings page and then scrolling down to GitHub Apps and then selecting the application that you own or just installed. The installation ID should be right in the URL bar, as you can see over here. So just copy this number and you can just drop it over here. Otherwise, there are obviously tools that will allow you to fetch this installation ID, but we're not going to go through that right now. I've explained them in other videos. Next, the final part, which is to define the GitHub app private key. I have moved my private key, the PEM file, to a location that is, again, secure. And I'm just going to read that file and it's going to be fed into this little row. Then I'm just going to copy this whole command and I'm just going to drop it over here, and then we're going to run it. And as you can see, the secret has been created. Now let's verify that the secret is in the correct shape and format. So you can do the following: kubectl describe secret and then provide the name, Nebu GitHub app, and then provide the namespace, arc runners. And you should see here that the data is actually correct. So we have the GitHub app ID 6 bytes, installation ID 8 bytes, and then the private key is 1600 bytes. If this number is less than what you're seeing right now, that means you potentially have a problem and that the content of the private key is not correct. You might want to double check the command before you continue. Otherwise, you're going to have a lot of problems and it's going to be painful to troubleshoot this. So let us go back to our values.yaml file and let us embed this newly defined secret over here. And let us change the value of this to Nebu GitHub app, right? That's how this one will work. Obviously, what we want to do also is to comment this line, because we're obviously not going to be using the GitHub token, and we're just going to be using the configured secret. So GitHub config secret as well as the GitHub token are both going to be commented out, and this is going to override that other configuration. Next is the proxy. A lot of enterprises would want to use a proxy in between the listener or the controllers and the GitHub API endpoints, as well as the actions backend endpoint. And this is where you can configure your proxy settings. Now, the proxy configuration is pretty simple. You need to specify the URL for your proxy as well as the port you're going to be using. And then you can also specify credentials for the proxy you need to use. And this could be a secret that has a username and password as key, just like we defined this other secret, right, from literal. So you need to specify here for the proxy another secret. This should be username and this should be password, and you should have values for those. Then we're going to be pulling this secret and we're going to embed it or append it to this URL so that we can authenticate. Also, you could use a anonymous proxy like we are doing right here, and you don't really need to provide this credential secret ref. You can just comment it out, and you're not going to need a proxy. Obviously, I have the no proxy parameters over here. Now, a couple of things you need to keep in mind. Whenever you specify this proxy, they're going to be applied to the controller, listener, and to the runner as environment variables. For the controller and the listener apps, these are going to change the behavior of the HTTP client within the app so that all of the traffic and all of the requests that we make are going to go through the proxy transport that we have configured over here. However, on the runner's level, they're going to be specified as environment variables. So if you have an application on the runner that does not recognize or does not abide by pulling the proxy configuration from environment variables, their traffic from that particular app are not going to go through the proxy. And you need to figure out other mechanisms to define this proxy configuration on the runners. We are not responsible for making sure that the proxy configuration works on every single potential app you might be running on your runner. We can only guarantee that our runner binaries are going to push their traffic through the proxy configuration, and they will. We know that. It's tested. We know very well that it does. We have end-to-end tests to prove it. If there's anything that's not working, it's probably because you have changed the runner base image, or you are using some other configuration that does not recognize or removes the environment variables that we are injecting to the runner. Some problems that you might face with proxy, and again, this is a nightmare. All of the different problems you're going to be seeing are probably going to be related to the proxy. Every time a proxy team creates a proxy configuration, they claim that it's working perfectly. And then after days and weeks of troubleshooting, we end up realizing that it's actually the proxy. So if it's not DNS, it's the proxy. Verify your proxy configuration very well. Make sure it has access to these different endpoints. What is more important is you make sure that this setup actually runs properly with the proxy, and you need to keep on troubleshooting it. We know very well that the proxy configuration works, but you need to test it. Your environment could be completely different than any other environment. So in order to activate this, just uncomment all of these lines and supply the proxy configuration, and then you should be good to go. The next step is to configure the maximum and minimum runners. Here you can uncomment it. You can uncomment the maximum runners, and you can specify that you want like a maximum of 10 or 100 or 1,000, whatever. There's no upper boundary. Or if you leave it uncommented, that means that the controller is going to scale until it hits resource limits. That's how it's going to work. Minimum runners, if you don't specify it, that means it's going to scale down to 0 by default. If you specify it to be 0, it's going to scale down to 0. If you specify it to be any non-zero number, like 5, it's going to scale down to this number always. So it's going to make sure that you have 5 runners always available and ready in idle mode to be picked up. This is good because for the controller to spin up a runner, especially if the runner image is substantially big, it might take 30 seconds to 1 minute, maybe 2 minutes, depends. A lot of variables could come into play here. If you use our image, it shouldn't take more than a few seconds. But if you have a bulky, big image for the runner that you're using, startup time could take quite a while. A remedy for this is to specify a minimum number of runners that are always idle and ready to be assigned to jobs. The minimum number of runners cannot exceed the maximum number of runners configured. The next item is to specify runner groups. So this is where you can control the permissions that these or the repositories that can access this runner skill set. So for example, on the organization level, I can go and I can create my own runner group. Let's actually do that. The runner group, if you specify it here, it's not going to be created on your behalf. So you need to create the runner group yourself first, and then you can specify it in the values.yaml file. So I'm going to go to actions, I'm going to go to runner group, and I'm going to create a new runner group here. I'm going to call it custom group. And then I'm going to specify that all of the repositories in my organization can access this with the exception of public repositories, and all workflows can actually access this group. Once I have created this custom group, I'm going to go back to my configuration. I'm going to uncomment over here, and then I'm going to change the value of this runner group to become custom group. That's it. And then the runner scale set is going to be created in that group. The next step is to specify the runner skill set name. This is very important because the way you're going to configure your workflows to target a particular runner skill set is using this name. Labels, they don't work anymore. So you cannot have a runner skill set with multiple labels like self-hosted, Ubuntu, 16 gigs, whatever. These will no longer work, and you cannot use runner skill sets like this. That's why it's very important for you to create runner skill sets names that are quite indicative. So for example, if you are using a container image that, for example, is Ubuntu based, you could say here, Ubuntu, Docker and Docker, and maybe a resource limit would be like 16 gigs, let's say. This could be a runner skill set name. You could also say Ubuntu 20-04, and then without Docker and Docker, 16 gigabytes, whatever. You can use any variation here as a name for the runner skill set. If you don't specify a runner skill set name, the installation name for the Helm chart is going to be what's used as the runner skill set name. Gonna show you, just like we did when we did Helm install and then we specified an installation name, we called it arc. If you don't specify the value here, this will override the installation name. If you don't specify it, then we're gonna default to the installation name. Now moving on to the second nightmare all enterprise administrators have to deal with are self-signed, not necessarily self-signed, but like certificates that are signed by a custom certificate authority. And this is quite popular within larger organizations where they have a root CA that signs all of the intermediate certificates that are being used. And this is very relevant in the case of using GitHub Enterprise Server, for example, where you can upload your custom certificates and the key that has been signed with them so that they can be used. Now, that means that the TLS handshake cannot happen between the listener and GitHub Enterprise Server, for example, unless these certificates are also trusted by the controller, listener, as well as the runner. Otherwise, all of the API calls that are being made using TLS are going to fail, claiming that this is a self-signed certificate and, there's a problem from a security standpoint with that. And this is why we also provide the option to configure your own, certificates for Arc. However, this is quite a complicated topic. So first of all, you need to understand the following. This certificate cannot be trusted automatically on the runner. What we can do is, if you are reusing our runner image, so for the listener pod and the controller, we have full control over them. That's not a problem. We will deal with it. However, for the runners, if you are using our runner image, what we will do is, if you provide the proper configuration, we will create a new GitHub server TLS cert volume in your cluster. And then we're going to mount that volume onto your runner in the appropriate location. Okay, it's going to be mounted to the mount path that you specify. And then it's going to be, whenever we run the runner, we're going to run update CA certs, which is going to take that certificate and trust it, add it to the trust store of that runner. Now, if you change the runner base image, this will no longer work because this works on Ubuntu-based images or Debian images. If you use something like, I don't know, CentOS or some Red Hat distribution, this is a completely different process and this will no longer work. Obviously, you can change the mounting path, so you can put it somewhere else. If the operating system has a location from which it trusts or it automatically adds at startup the certificates to the trust store, this is how you do it. If that's not available, then you need to configure your runner image to read from this mount path and add the certificates in this mount path to the trust store. You have to do that and you have to manage that yourself. We cannot really predict how that is going to be done. The second thing is, it's going to set node extra CA certificates environment variable to that mount path that you specified, which will allow node to also add these certificates to the trust store because, node is quite special and it needs its own mechanism to trust certificates. And the last thing is, it's going to set runner update CA certs environment variable to 1, and this will instruct the runner to reload the certificates on the host. This is the last part, which is what reload means, it's going to add them to the trust store for that container. So in order for this to work, you need to create your own config map that where you specify the name and the key. So what does this actually mean, and how can I really create this config map? Let me show you an example. So let's assume I'm going to create a dummy certificate right now. So let's assume I have this certificate file. I'm going to call it, my custom ca.pem. It's very important that the certificate you're trying to use is PEM encoded. Any other format will not work, PSK and all of these other variations. It has to be PEM encoded, right? And then the next thing you need to make sure of is that not only it's PEM encoded, but it also has the extension .crt. This is not our requirement. This is the requirement of Ubuntu, the operating system. It will not recognize certificates that have the extension .pem. They have to have the extension .crt. After you have the certificate, rename it and make sure that it has this extension. Then what you can do is you can create a config map with this configuration. Okay, again, just to show you how this is done, let's open up a new file. And so let me break it down for you. So kubectl create config map, and then you can specify a name for that config map. It can be whatever you want. It doesn't really matter. And then you can specify the from file. So in our case, where did we put the certificate? Let's have a look. So we copy this one from here, and you can specify it like this. And then what did we call it? We called it my custom ca.crt. Right? So this is how it's going to look like. When you specify it like this, that's it. That's all you need to do. And then when you create this, it's going to create the config map with the content of that certificate. But because the file is empty, let's first add some stuff to the certificate. Let's assume, there's whatever. Let's say begin certificate, blah, blah, blah. And then let's add this to my custom, just so that I can show you the content once the config map is created, right? So again, let's run this one more time. kubectl create config map ca cert. Oh, we need to specify the namespace. I forgot to do that, sorry. -n arc -runners. So you will notice, right, that the namespace I'm using here is different than the namespace I used previously. Just because the listener is going to be configured in another namespace. It's not going to put the listener pod in another namespace, but it's going to create the runners in that new namespace, right? The listener pod and the controller manager are always going to be in the same namespace, but you can split where the runners are created, and you can have those created in a separate namespace. And this is what we're doing here right now. And that is why also this config map needs to be in the other namespace, because we're going to be using this config map to install this certificate on the runners themselves, and the runner pods need to have access to this config map, right? Otherwise, we're going to have a problem. So that's why we are using this particular namespace. Now, this might fail because the namespace has not been created yet, which is fine. Also, we can create it. So let's first of all test it. Correct, it failed because the namespace doesn't exist. So let's create the namespace. kubectl. Okay, let me clear first of all. So kubectl create namespace arc runners, and the new namespace has been created. Now if we make another attempt to run this function, run this command, it should work. If we want to verify this or verify the content of this config map, we can say kubectl get config map ca cert. That's what we called it, right? And then -n arc runners -o YAML. And then when we print it out, you will see here that this is the data. This is the content of the certificate, which is exactly what we had as part of that file. And then this is the key, right? And the name of the config map. Great. We have what we need. So we can use this same configuration in our values.yaml file now. So we can go here and we can uncomment all of these. So let's do it like this and delete word and then repeat. All right, cool. So here we can specify the name, which we called delete end, and then ca cert, and then here is the name of the certificate, which we called my custom ca.crt, and then this you can keep it to the default unless you have changed the base image or for whatever reason you want this to be mounted in another path. If you keep this path, then the runner will make sure that it loads and runs the update ca certs application to add this certificate to the trust store. And this is pretty much how you can configure your TLS certification. And again, if you see in the logs TLS certificate problems, That means you either have the wrong formatting for the certificate, you could also have the wrong file name, or it could be mounted to the wrong directory. So you need to inspect and make sure that the runner is actually updating the certificate in the trust store correctly. Okay, these are things we cannot guarantee ourselves, and this is done on a best effort basis. Many things could go wrong here. Your configuration could affect this tremendously, and there's really no way for us to really identify all the possible configurations and deal with those. Okay, now moving on to yet another complication, but we still have to talk about it. Container mode. And this is a point of confusion for a lot of different people, but again, this is where Kubernetes is not really ideal for these scenarios. That's why at the beginning we hesitated really in adopting this project, because is really Kubernetes the proper place to have CI workflows running and to managing self-hosted runners? This is yet to be determined. A lot of people are finding success with this, but you will see. So container mode, what's the limitation and why do we need it? In GitHub, you can have workflows where you could build container images, or you could run images, or you could run containers as services, or you can run container-based workflows, whereby you can have a bunch of steps that run inside a container image that you specify. When we are running inside a Kubernetes cluster already, that means we are using containers for our self-hosted runners. And that also means that you cannot really run Docker inside these runners, by default at least. That's why we need to rely on something called Docker in Docker, whereby we need to install Docker inside these images, or at least use the Docker in Docker image, which comes with a bunch of own customizations and configurations. And unfortunately, due to how Docker is designed, and this is a limitation that we cannot really work around, these containers need to run in privileged mode, because these containers require high privileges to access the Docker socket, and that is why Docker in Docker exists. And what Docker in Docker allows you to do is, it allows you to spin up a container within another container, right? Because we have the container which contains our self-hosted runner image. It's running our self-hosted runner image, and then one of the jobs needs to run inside that runner container itself, right? So that's why we need Docker in Docker. Docker in Docker is going to create another container inside that original container, and it's going to run that workflow, or it's going to do whatever. Now, the problem with this also is that you cannot build Docker images using this approach. Okay, let's be very clear about that. So if you want to build images, you need to rely on other solutions. So Canico, for example, would be one of the options you could use to build container images if you're running in this particular mode. Now, another alternative for this is, because sometimes in clusters you cannot really run privileged mode. So the alternative is to use Kubernetes mode. And what this means is, we have a solution we created, which is called runner container hooks. And runner container hooks is a simple app it's a simple Node.js utility that is installed along with the runner binaries inside the runner image. So if you use our version, this ships already with that runner. And what this will do is, whenever you have a job that uses container mode or uses another container as a service, right? The container hooks is gonna try to connect to the Kubernetes API, and it's gonna tell Kubernetes through the API to create another pod that's gonna be running your container job next to the pod that is our runner, right? So there's gonna be our runner, and then there's gonna be another pod which is gonna be our container job or service. And of course, in order for that to work, you need to provide the following permissions, and it needs to have access to the Kubernetes API, and it has to have the ability to, create and fetch and delete pods from that particular namespace, right? But because we have our runners isolated in a namespace, that should be okay, because then the container hooks can spin up new pods only within that particular namespace, and you should be okay. So this is another viable solution. It doesn't really solve the building process or the building problem, but it also allows you to avoid using Docker in Docker and running containers in privileged mode. So you have to choose either of these options, okay? There isn't a third alternative. So let's start by configuring, Docker in Docker in this case, and I'll show you how it works. And in the second runner scale set, which I'm going to spin up, I'm going to try to configure the Kubernetes mode so that I can see how that works. So for Docker in Docker, all you have to do is just to uncomment these. And that's it. Once we have that specified, that's all we have to do. Okay, so the next step is to specify the template and the pod spec for the runner pod, right? We don't have to change much here unless you are running your own custom runner image or something, but let's go through it anyway. So template, and because we changed the container mode to Docker in Docker, we're gonna inject some extra stuff for you inside this template, right? Because we wanna create an init container, and that init container is going to be executing this command. So it's going to copy all of the externals to that mounted volume, and it's going to be Docker and Docker externals. Why? Because we need to share these externals in between Docker and Docker and our runner, right? This is how the behavior is going to work. We need to share these binaries that are available in this directory between the two, and that's why we need to create a volume mount that is shareable between these two containers. And the only way you can do that is via an init container. So a new container is going to spin up and it's going to do this work for us. And then we have the runner container. This is the configuration. Obviously, if you want to change something, this is the place to do it. So you can specify the different image, you can specify whichever tag you want to use, you can add more environment variables, or you can just rely on the defaults that we specify. Now we are sharing all of this with you because if you want to override any of them, this is the place to do it. Otherwise, if you keep it by default, this is the configuration that's going to apply. So that's the first container, the second alongside the init container. And then we have the third, which is Docker in Docker. It's going to use the Docker in Docker image. It's going to run in privileged mode, and it's going to mount all of these different volumes to these paths. These volumes are also going to be created. And that's pretty much it. I'm going to keep it vanilla for now. Obviously, if you're configuring these, then you pretty much know what you need to do. I'm not going to uncomment any of them because I want to keep the configuration to the default. So here, this is the spec for our runner container. That's what we're going to apply. We're just going to use the latest version. Obviously, we don't recommend that you keep it like this because we could be upgrading at any point in time, and I think you should be managing when you upgrade your runners. So I'm going to switch this to using version 2.306.0, which is the latest. And then the executing command or the entry point is going to be run.sh. That's pretty much it for the runner skill set. Obviously, if you create your own service account, just like we said with the controller, if you create your own roles and role bindings, this is the place where you can specify them, right? So you uncomment these and you specify the namespace as well as the name for the service account that you'd like to use. But then you are responsible for all of the permissions and privileges required for the listener to operate and the controllers to operate properly. You can read our Helm charts to understand what is needed at that point. And I already showed you in a previous section where you can find that information. Now that we have all of our configuration ready, we can proceed with the installation. However, before we move on, I need to comment out this section because obviously my certification is not correct. So I don't want this to ruin my installation. Then we're going to have to go on a troubleshooting hunt and all of that stuff, right? And just like we did before, let us try to craft the command with which we're going to be able to install this runner skill set. So the command in our case is quite simple and it's very similar to the one from before. Helm install, and then we're gonna specify the installation name. But as you recall, and we talked about it, this installation name is just gonna be for the purposes of managing our Helm installation, and it's not gonna be the name that's gonna be used to target our runner skill set because we have overridden this name in our values.yaml file. Okay, so this is not gonna be the name that's we're gonna be used in the runs on value in our YAML file. So we can call it whatever we want. I'm gonna call it arc runner set, and then let's go to the new line. We're going to specify the namespace and we're going to call it arc runners. It's very important here to use the same namespace that we used when we created the secret, right? So we have arc systems and then we have arc runners, and that's what we're going to be using over here. Now, obviously the listener pod is going to be created in the same namespace as the controller manager pod. So don't confuse these things. However, the runners are going to be created in the new namespace, which is going to create this security separation and isolation, which is good. Then we're going to specify create namespace, but we know that this namespace exists already, but still it doesn't hurt. And then -f, and then we're going to provide the location of this file, which is in my home directory, and then code spaces, and then arc configuration. Oops, there's something wrong with my, our code space, actually, arc configuration, and then runner skill set 1, and then values.yaml file. And then we're going to specify the link to the package, right, where our Helm chart is published. So this is going to be it. And make sure here that you're using the GHA runner scale set chart and not the GHA runner scale set controller chart. And this is the distinction. So you can configure as many GHA runner scale set Helm charts or installation as you want, but you can only have one controller. All right, the next step is to specify the version of the Helm chart we would like to use. And also you can skip this if you want to use the latest version. And now we are ready. Let's hit enter, and then you will see that the installation has been successful. Now, let us do a quick check, helm list -a, and you can see here that Arc Runner Set has been installed or deployed, and the version 0.4.0. Perfect. But this is not the end of it all. So let's first of all make sure that our pods are up and running. So kubectl get pods -n arc systems. And we need to see two pods over here, right? Which are the controller and then a pod for the listener. This means that we have a very successful installation. If you don't see the listener pod, then you have a problem. And there could be many problems over here. So the proxy could be misconfigured. You need to go and figure out the proxy settings. The TLS certificate could be misconfigured. Then you need to go and figure out the TLS configuration settings. If you don't see the listener, that also means that the secret that we have created, either the personal access token or the GitHub app, is incorrect. Either the format or the structure of the secret's data is incorrect, or the reference is incorrect, or many things could go wrong in that particular section. So if the listener doesn't go up, then you have a big problem. Now, if the listener goes up, then we are probably in a good state, because if things worked well so far, it's highly unlikely that they will take a wrong turn. But still, things could go wrong. Everything is quite complex when it comes to these things. Now, if things go wrong, what you can do is you can inspect the logs of the controller, right? So if you don't see the listener, you can start by checking the logs of the controller. And if you see errors, then you need to start addressing these one by one until you resolve all of the problems. So you can go about it like this, kubectl logs, and then you can fetch these logs and see what's going on. As you can see here, there are no errors. So you can see only info, which is like fine. It means everything is running smooth and as it should be expected. A couple of things also to note. That we have specified a minimum number of runners. So we should see 5 runners also spun up in our cluster, but they are in the second namespace, right? So we can say kubectl get pods -n arc runners, and we should be able to see 5 runners that are currently in an idle state. Also, you can see here that we have 2 containers inside each pod. Why? Because we have configured the container mode to be Docker in Docker. So if you only see one container running inside the pod, that means you have a problem and Docker in Docker is not running as it should be. What you've just seen right now is all thumbs up. Our setup and configuration has been spot on. We have no issues whatsoever. And now we can start using these runners in our workflow. So let's go back to our values.yaml file, because I need to get the name of the runner skill set. So the runner skill set's name is the following, Ubuntu 20.04. So let's copy this because I need it. And then we're going to go back to our organization, and then we're going to go to our actions tab and then runners. And then here you should be able to see the runners, right? Because we have 5 of them. And then you should be able to see the runner skill set, which is this one. And it belongs to the custom group. And if you click on it, You should also be able to see a small view which shows you the number of available jobs, assigned jobs for this runner scale set, busy and idle runners. This is obviously going to change. We are working on improving the UI, but it hasn't landed yet. Before we move on with the demo, you're going to notice a couple of small changes. First of all, my t-shirt color has changed, and this is because I'm recording this demo on a different day. I bumped into a small technical hiccup on the original day, and I was not able to solve it in time. And the second change is that I'm using a different organization. Don't worry about these changes. They're not going to affect your setup in any way, shape, or form. I have the exact same repository workflows, configuration, and everything on the new organization as the old one. I just wanted to clarify things to avoid any confusion. You will notice here in this repository that I have a simple workflow that I'm going to explain right now what it means. It's the short sleepy matrix. This workflow takes 2 inputs and it is executed on demand with a workflow dispatch. The first input is the actions runner scale set name. I wanted it to be configurable because I wanted to do multiple demos and I really didn't want to hard code the name of the runner scale set in the workflow. The second input is a delay of a number of seconds. And this is because this workflow will run a job matrix, which will run 3 concurrent jobs. And for each one of them, it's going to use my input of the runner scale set name as the input for the runs on property over here, which means that these jobs are going to run on my runner scale set, and Arc is going to spin up the runners to get these jobs assigned to and execute them. And I only have one step, which is going to echo the name of the matrix version, and it's going to sleep for the duration that I have specified. This gives us a little bit of more time to see what's going on the other end. Now let's get a sample workflow run happening. We're going to go to this workflow, and then we're going to go to, let me put them side by side just so that you can see what's happening. I'm going to click on run workflow, and then I'm going to paste the runner scale set name. Remember, we called it Ubuntu 2416G. And then I'm going to specify the duration to sleep of 20 seconds. And then I'm going to run the workflow. And as you can see here, we're going to have a run. There we go. You will see I have 3 jobs. And if I click on one of them, you will see that these jobs have been assigned to this runner scale set, and they have been assigned specifically to this particular runner. And the job has started execution now. And if I go here, this is my cluster. You can see I have the listener and the controller up and running, and I have 5 running runners already. So the job is going to execute on one of them, and in this case, it's going to be this one. And if I inspect the logs of this runner, you can see here that all of the, the job is actually executing, and when the runner is done its work, it's just going to exit. And then when it exits, the controller is going to clean up this pod. And because we have defined a minimum number of runners, it's going to create 3 others because we have 3 jobs. So 3 of the runners we have already set up were executed their work, and then they exited. And then the controller is just going to spin up 3 other runners to make sure that we meet the desired minimum count. Okay. If the minimum count is 0, then you will see no runners being spun up instead of the ones that executed the job. And you're going to be able to scale down to 0. That's it. Now let us see a more complicated workflow that demonstrates how you can use the Docker in Docker feature. So in order to test out Docker in Docker, I have another workflow that I'm going to be using. It's called test service container. And this workflow is pretty much the same. It gets dispatched with the workflow dispatch, and then it's going to run a job on my runner scale set. However, this time it's going to try to set up a service container, which is going to run Redis. And I'm going to use the container busybox as my main container where I'm going to be running the job. And then I have this step over here, which is going to simply run a hello world, and then it's going to sleep for 360 seconds. And it's also going to have a couple of environment variables, which is the Redis host, as well as the Redis port. And then I'm going to have the service Redis, which is going to use the image Redis to be created alongside my runner container in the same pod, and I'm gonna have access to Redis from my runner container. And this is good if you want to test, for example, a scenario where you need to connect to another service like Redis and you want to execute some behavioral testing inside your runner. This is the way to go about it, and Docker in Docker will facilitate this for you. So let us see how it works in action. I'm gonna jump to my Actions tab. I'm going to go to my test service container workflow, and then I'm going to click on run workflow. And I already specified the workflow, the runner scale set name over here. So I'm just going to run another job, and I'm gonna go and inspect it. You can see I already have one running. You can ignore that one. And if I go and see to which runner it was assigned, I can see here that it's assigned to this particular one, which is already in my list over here. So now I can actually go, and you will see here that I have the Docker in Docker container. This is the pod. I have the Docker in Docker container. I have the init container, which is supposed to do the configuration and, copy the externals working directory. And then I have my runner. Now the Docker in Docker is running my Redis service, and the runner is running my job, which already has access to Redis. And let me demonstrate this for you. I'm going to execute into the container, and I am going to start by installing Netcat, just so that I can demonstrate how I can connect to Redis. So we're going to start with an apt-get update. That's the package manager for Ubuntu. And then I'm going to install Netcat. And Netcat is just a nice small utility which allows us to connect to a host and a port. And then if I do a Docker PS, you can see here that I have the Redis container running, and it's open on the port 6379. So if I do the following, nc 127.0.0.1 36379, I'm now connected to Redis. If I say something like hello, you will notice here that this is the Redis server, and it's running version 7.0.12. If I go into the Docker in Docker container, and then if I list the running processes, you will see that the Redis server is already up and running on the port 6379. It's as simple as that. All right, now what we want to do is to try to configure our second runner skill set, and we're going to enable it in Kubernetes mode, where container type is going to be Kubernetes mode as opposed to Docker and Docker. First thing we're going to do is I'm going to remove the values.yaml file from this directory, and then I'm going to copy the one that is in my previous configuration. Why? Because we're just going to change it a little bit, and yeah, I don't want to start from scratch. Let us jump to the top and just verify very quickly. Config URL, pretty much the same. Nothing's going to change here. For the secret, also the same, nothing's going to change. We're not going to use a proxy. Maximum and minimum runners are going to be the same. Runner group is going to be the same. We're going to change this to Debian as opposed to Ubuntu, just to create some variation. And then we're going to change the type here. So instead of Docker and Docker, we're going to specify this to be Kubernetes. And then what we're going to do is we're going to remove the comments here because they're needed. And then we're going to fix the indentation. Otherwise, we're going to have a problem here. So these need to be on the same level. Storage class, resources. I think this should do it. If the YAML complains, we will come back and fix it. For the template, everything is going to remain the same. However, I need to draw your attention. Okay, so this is what's going to be injected if the container mode is Kubernetes, right? So the template spec is going to change, and this is going to be the spec for the runner. And you can see there are a bunch of additional environment variables that have been added. One of them for the path of the container hooks. The second one is for the actions runner pod name, the new one that's going to be created. And then this one is for making sure that if the workflow does not have a container job, it's going to fail. So it's important for you to disable this. Why? Because otherwise you're going to see different types of failures happening. Because if you have a runner skill set that is configured only to run container jobs, that's totally fine if that's how you want it to be. But usually it's a pitfall that many people fall into, whereby they don't know that they can disable this behavior with this setting, and then they assume that Kubernetes mode only works for that type of workflows. That's not true. We're going to disable it. The rest we're going to keep the same because it's, the similar volumes, the claims. I'm not going to change those. You can obviously configure those on a need basis. I'm going to skip them for now. So let us add the environment segment over here, and let me paste this. All right, there we go. And I'm going to switch this to false. And that's it. This is the only configuration I'm going to do. I'm going to save this file. Something caught my attention here. All right, the volumes. I think this is fine. Cool. I'm going to save this file right now. And before we install this, first, I mentioned that we're going to be using persistent volumes. And you can either create these volumes yourself, make a number of them available, but that's problematic because obviously that's a manual effort that you always need to do. So whenever a new runner spins up, it needs to claim a new persistent volume. And if that happens, then if you create 10 volumes and you create 10 runners, that's it. The volumes are gone, you know? You're going to have a problem. That's why I personally am going to use in this setup a dynamic local provisioning, local persistent volume provisioner. It's called OpenEBS. You can pretty much use anything else you want. For me, this is the easiest setup that we can do. So first of all, I need to install OpenEBS before we can proceed further with Kubernetes mode. So be aware, you're going to need a solution for this particular problem. How do we install OpenEBS? With just a couple of extra Helm charts, again, that we just need to make sure they are available. The first step is to add the OpenEBS repository. So we can do that with helm repo add OpenEBS and then add URL. The second thing we can do is helm repo update. Done. And then we can say helm install OpenEBS and then specify OpenEBS. Sorry, I'm just making sure that I don't have typos. Namespace, we're going to put it in OpenEBS and then we're going to create the namespace if it doesn't already exist. Obviously, all of this stuff is configurable, so feel free to change this whichever way you want. And then let's make sure that we are up and running. As usual, I'm just going to access my favorite tool, K9S. And as you can see here, I have my controller, I have my previous listener, which we configured. I have my 5 runners up and running already. And then let's scroll down a little bit and you can see here that I have the OpenEBS, provisioner, MDM, and operator all up and running as they should be. Everything should fall into place right now. No further configuration is required. If you're in this state, then I think you are in a good shape. Now, the next step is for us to install the new runner skill set, just like what we did before. So let me find that command. Helm install, what was it? Arc. Runner set, this one. Yeah. So let us use this one, but instead of this, we're going to call it Debian runner set, and then we're going to keep the same namespace. However, this time we're going to change this directory so that we can point to the new values.yaml file, right? Otherwise, you're going to install the same old configuration. So please make sure you don't fall into this trap. And then we're going to install and hopefully everything goes smooth. Perfect. It says that it's deployed, but again, we need to verify ourselves and make sure that the listener, the second listener, is up. If it is up, that means our configuration was successful. So let us have a look. And yep, the listener is up. And as you can see here, also the 5 minimum required runner are preparing themselves. And obviously, you can inspect all of these configurations, right? So if I describe this listener, for example, I see a lot of valuable information here. So I can see that it has a label where it says the name of my organization. And we do this on purpose. We add a label. So if it's configured on the enterprise, by describing the listener, you can see to what's the target of its configuration, whether it's an enterprise, organization, or repository. Then you can see also the scale set name, the scale set namespace, which component it is, and what it is part of, what is the release version, as well as the runner spec hash. You can see a bunch of other files like the image that we have used. Right? And what are the different containers that are part of this pod? You can also see the command that we have started in this pod for the container, and you can see that this is the listener, as opposed to, for example, if I go and describe the controller, you will notice here that the command is actually manager, right? And this is what's going to create the distinction from the same controller image, which application we're running, whether we're running the controller or we are running the listener. And also you can inspect here the arguments that have been passed to the manager. So if you change, for example, the log level, another argument is going to be passed. If you change the log format, another argument is going to be passed. So there's a lot of useful information here. Now, I'm not really sure why my runners are not up and running, so let us describe them and see. Most likely it is something to do with, there we go, the provisioner, the persistent volume claim. So I think there's a mismatch between what I configured versus what OpenEBS is provisioning. So I will double check this. Give me a second. Okay. I know the issue. Let's go back to our values.yaml file, and we're just going to modify a couple of things here. The storage class name should actually be OpenEBS host path. And then I think the rest should be the same. So let us deploy this and see if it's going to work. How do we upgrade the configuration? Same command as before. Let's find it. But instead of helm install, we do helm upgrade, and then we pass -- install. What this will do is it's going to upgrade the configuration as opposed to installing a fresh one. What that does is if you inspect the namespace, you will see here that the listener is going to be recreated and then the runners as well. And hopefully this time everything will work as expected. Let's see. I just described it, and there we go. They started coming back up online. The slight delay is because OpenEBS needs to provision these different persistent volumes. Let me see if I can see them. PV, PVC. There we go. So these are the persistent volume claims. And you can also see the PVs. These are the persistent volumes, 1 per runner, 1 GB each, read-write access, and then they get deleted once these runners are down. So let us go back to the pods, and yeah, I think this is it. This is our setup. Now these runners, just like the others, be used in our workflows, and we can easily target them and have different types of workflows running on them. The way we're going to test Kubernetes mode is using the same workflow we used in the Docker and Docker scenario with the first runner skill set. Why? Because I want to show you the same workflow using the same service container and how that looks like in the cluster itself, so that you can understand the differences without much changes in the initial setup and variables. So let's do that right now. Again, as a reminder, this is my workflow. We're going to test service container. And because the runner skill set name is configurable in this workflow, we're not going to change anything, and we're just going to jump right to the execution. We're going to click on the Actions tab. We're going to go to the test service container. And then, again, as a reminder, we called this workflow Debian 200416G. So we're just going to change this to Debian, and we're going to run the workflow. You can see here on the right-hand side, I have my cluster. I have the second listener for the second runner skill set up and running. And I also have 5 containers running. And also, immediately you can observe a difference. In these containers or these pods, I have only 1 container, as opposed to the ones who have Docker and Docker, they have 2 running containers. Okay, so you can see right now, what happened when I ran this workflow is that something new came up, this one. And this is the pod that I mentioned that's going to be created using the container hooks. So the pod that's actually has the runner is going to be the one that's referenced here. So it's the one that ends with 7LGH4, which is this one. And then a new pod is created with 2 containers in it. And this is the second one that's going to contain actually our service. And these 2 pods are obviously connected networking wise. So let's have a quick look at what's inside of it. So you can see here in the second pod, we have the BusyBox and we have Redis. So both of these are going to be running in the same pod. Why? Because they need to share the same network. If they are across different pods, things become a lot more complex. So what happens is we have the initial pod, for the main workflow run, and then we have a new pod that's created with the container job as well as Redis. And if we repeat the same test as before, we're going to have the same exact outcome. So if I go into my BusyBox container, and I run bash, you'll notice first of all that Docker doesn't exist here. And now you'll be asking but how can I connect to the second one? Well, these share the same IP address, right? So if I do nc 6379, I should be able to connect directly to Redis from this particular container. And if I type in hello, you'll notice here that the Redis server responds. And mind you, if I try to list the processes running here, you'll notice that the Redis server is not running in this container. It's actually running in the second container. They share the same pod space, and that's why there's direct connectivity between them And that's how you need to think about this. That's it. Honestly, it's not that complicated. If the job, once the job completes and once the timeout is over, the delay that I have injected, this container here, this pod over here, plus this pod over here with all of the containers in them are going to be removed and recreated. That's pretty much it for Kubernetes mode. That's all I had to share with you. I hope you enjoyed this video as I enjoyed making it, and I hope you found it useful and beneficial. And if you did, please consider supporting my work. There are many ways to go about it. You can either become a member of this channel, you can join and subscribe as a Patreon, or you can also do a one-off donation either via YouTube or via Buy Me a Coffee. Another way also is to buy a copy of the knowledge graph, and the very least, just like, share, and comment on these videos and everything I post. This really helps me keep going and keep producing content that is hopefully useful to you. Thank you very much for watching, and I will catch you next time.